Welcome. What I'm going to do in a few short videos is really talk about some things that kind of pop up every so often when we do calculations. And engineers really need to understand the concept of units. That is measurements. You know, we're doing calculations, we're doing measurements and so forth, and we sort of report these measurements, right? So we say something like we talk about speed, or we talk about distance, or we talk about a rate of change of speed or whatever. So in the chemistry modules, for example, we talked about energy, right? So what is really important is for us to understand the concept of units, how we use the different fundamental units and combine them in different ways to make some sort of sense out of them, as it were. Okay, so let's start with what I would call the fundamental units. These are the sort of things that sort of almost it makes sense when you think about them, right? So let's talk about the first one. We call that mass, right? So a mass of something, kilograms, grams, pounds, and so forth, right? Now I won't get into how do we define what 1 gram is, if you will, but you sort of know, 1 gram is the mass of something which is equivalent to a gram as defined by a standard, right? The second fundamental unit we're talking about is something called length. By that I mean, we know 1 centimeter or 5 centimeters or feet or kilometers and so forth. So that fundamental unit is called the unit of length. Okay. The third fundamental unit is that of time. So like seconds and hours and minutes and so forth. So it's just amazing, just using mass, length of time, we can derive other variables, as it were. So for example, speed is the ratio of length over time, right? So we don't need to have a fundamental unit of measurement called speed or unit called speed, but if you know length and time, if we take the ratio, that gives us speed. We can even define things like force, which is really mass multiplied by acceleration. And acceleration is the rate of change of speed. And because we know what speed is, it is really can be easily derived from them. So many of the quantities that we use in engineering, are made up essentially as using these fundamental units called mass, length, and time. There is one more very, very important concept, fundamental unit as well, that has something called temperature, right? And we talk about something being hot or cold. What we're really talking about is we use the unit of temperature to define something called something hot and something cold. And so, but of course, just like mass, it can define as grams and pounds and so forth. Temperature, there are different ways in which we can represent them. The ones that we are most familiar with are things like Fahrenheit or centigrade. Right? So like the current temperature, say the temperature outside is 65 degrees Fahrenheit. And of course, we know how to convert Fahrenheit into centigrade and so forth. And this is something you can easily look up, but you can take Fahrenheit and minus 32 divided by and multiply by 1.8 will give you centigrade and so forth. So if you define temperature as Fahrenheit, we can calculate the temperature as centigrade and vice versa. The important thing as far as temperature is concerned is this is a very helpful way of describing what the temperature is, but for most of the calculations in engineering, we use temperature in the absolute scale. So for example, we use centigrades, as it were, but we typically use for temperature something called a Kelvin scale, Kelvin, K-E-L-V-I-N. So for example, if I have 20 degrees centigrade, my temperature in Kelvin is 273.15 plus the temperature in centigrades, right? So what's incredible about the stuff is that if you know mass, length, time, and temperature, we can define things like, as I said, force, we can define pressure, we can define units of energy, even in terms of joules, for example. So from the simple, if you will, fundamental units, mass, length, time, and temperature, we're able to describe phenomena by combinations of these mass, length, time, and so forth, right? And if you remember, in chemistry, we will talk about calories per mole, or calories, kilocalories per mole, right? The term mole also shows up. So what is the term mole? So in a sense, the mole is like a measurement of the amount of a material. The one difference is that mole refers to, the mole has, we use a molecular weight as a way to relate moles to mass. Okay, so to go back, so if I have, for example, mass of something, if I divide that by the molecular weight, I get number of moles. As an example, this is something that you all are doing in some problem sets, and we'll be doing this as we go along. So to give you a very simple example, if I have water has a molecular weight of 18, right? So if I have 1 gram of water and I divide it by 18 gram per mole, I have 1 over 18 gram moles. And typically when I have gram moles, we simply say moles. Okay, so in this video, the lessons are that if from mass, length, time, temperature, and molecular weight or moles, we can do a bunch of calculations which use these different fundamental units in different ways.